hard. We're a little bit beyond rational numbers, but it's okay. We'll go through with it when you do it, right? It shouldn't be that hard. Anyways, every grade, right? Grade 9, 10, 11, 12, whatever it is, you'll always be dealing with equations, right? Let's look at this. Triple inequality. How do we solve something like this? The first one there, D. What do we do on all three sides? Or actually, what would you do, the first thing?
Do you open the bracket?
Yeah, we can open the brackets. You'd get negative 2x minus 8, 6. What about now?
You add 8 on all three sides.
Right, so you get 8 is less than negative 2x is less than 6. What's next?
You divide by negative 2, and that
Right.
flips a sign.
Right, exactly. So negative 4, now it's gonna go this way, negative 3 at one end on final answer. Number line representation would be the answers between negative 4 and 3 with a closed circle because it is inclusive, okay? It's pretty simple, right? It's not that complicated. Let's see, some things a little bit more difficult. Let's try doing some of these. It says determine the solutions. So that's just another way of saying find what x is equals to. Find the x-intercepts. What's the degree of this entire thing?
Degree 6.
Nope.
Oh, degree 3.
Nope. 6 is out, 3 is out. So degree is going to be the biggest power, right? Once you open the brackets, though, this is not in the standard form. If you were to open the bracket, you would get this times this, right? You'll get an x4 component and nothing else is going to beat x4. So this is a degree 4 polynomial.
Okay.
The question is now, how do we find the x-intercepts? So you want to set, whenever you have something times something equals 0, what this means is either this guy is 0 or that guy is 0, okay? So you got to split them apart. So whenever you get something times something equals 0, it wouldn't work if it's like this times this equals 5. No, this is not 5. It only works when you have a 0 on the other side, like that. So when that happens, you just gotta kind of split them apart. So you would get either x cubed plus 2x squared is 0, or you would get x plus 9 equals a 0. If x plus 9 equals 0, what's x?
Negative 9 plus 9.
Yeah, so just x is negative 9. That's gonna be one of the answers. What about this one? How do we solve this cubic equation for x? Can we pull something out?
An x.
Right, you can pull out an x. X times, what are we left with? Actually, I can pull out more than just an x. Always pull out a GCF, which means the max things that you can pull out.
X squared.
Yeah, x squared. What are we left with in a bracket?
x plus 2.
Yes, good. So now look at this. We've basically gone back to where we started from. We have something times something equals 0. Whenever this happens, you just got to split them apart again, okay? So you have x squared equals 0 as one of them, and then x plus 2 equals 0 as one of them. So if x squared is 0, what's x?
It's just 0.
Yeah, what about the other one? X plus 2 is 0.
-2.
Right, there we go. So our x-intercepts are 0, -2, and -9. We know this is a quartic function with a positive. By quartic, I mean x4, okay? That's the degree of this polynomial. So a positive degree 4 polynomial starts here, it ends here, right?
Mm-hmm.
And we know the x-intercepts are 0, -2 is here, and there's -9 here. It could have a maximum of 3 turning points, right?
Uh-huh.
But look at this, it's coming down. There's an issue here in this part. From here to here, there's an issue because now we have an extra x-intercept. So that's wrong. What's the issue? We know this is right. We need to end up there. That's fine. But if I come down from 0, I have to pass through another x-intercept. Can you identify what the issue is? The issue is right here, actually, right here. Notice how at this x squared equals 0, we have a dual root, right? The root is 2 because of the squared here, you see?
Mm-hmm.
So what do we do? The turning point. There we go, that's better.
Okay.
Whenever you have something like, for example, if you had x minus 3 squared equals 0, that means at 3, there's going to be a turning point, okay? If it was x
Mm-hmm.
cubed equals 0, instead of it being a turning point, it will go like a mini cubic function through that x-intercept.
Mm-hmm.
Now here's a real life example of something like this. Someone's diving into the ocean, and her height is given by this function. So basically, we know this is a, what's the degree of this function?
2.
Right, opening up or down?
Down.
Down. So it's gonna end up something like this, right? It's gonna look something like this. What's on the x-axis? What's our x variable here? What's the independent variable? E is our independent variable, okay? Independent variable is always going to be the thing in the function itself, like here. You can replace that with an x, it's not going to make a difference. What does t mean in this context? T usually always means the same thing. It's in this sentence. See, what does t represent?
It's seconds.
Yeah, it's seconds, right? It's time. And time can never be negative, so we can just kind of kill off this bit here, you see?
Mm-hmm.
What does the y represent, which is h of t? What does this represent? And the clue to that is right here. That is a y variable, in this case, h of t. So that represents the height, yeah?
Mm-hmm.
So on the y-axis, we have the height. And this is in meters, and we have time in seconds. Let's go one by one. Question A says expand the height function. That's just a fancy way of saying open the brackets, right? So we have -5 t minus 0.3 squared. We need to open up the square element. How do we do that? We can just do this on the side, okay? Square just means it's being multiplied by itself. So like this. T minus 0.3 is being multiplied to t minus 0.3. Now look at this. We're gonna FOIL this. And whenever you FOIL, you go from here, here, from the t, now t is done. Then you go from the -0.3 here and here. Let's go the first one. What's t times t?
T squared.
Right, what's t times -0.3? It's -0.3t, okay?
Mm-hmm.
Now we've dealt with this guy. Now we go to this guy. -0.3 times t is another -0.3t. And then the last guy, -0.3 times -0.3 is positive 0.09. All right.
Uh-huh.
Are there any like terms here?
The 0.3 t.
Yeah, exactly. So you'll get minus 0.6 t plus 0.09, and there we go. That is our bracket expanded, but now there's a -5 in front, right? So we're just gonna multiply everything in there by a -0.5. So this is what we have so far. So far we just expanded the square element. Now we're gonna multiply by -5. What do we get? We multiply everything in here by -5.
-5t squared.
Yeah, that's the first one. What's the next term?
-3t.
Positive, because we're multiplying -5 with negative numbers. That's gonna become positive. And then the last one is gonna be -0.45 plus 25. And these two are like terms, nothing else is like terms. So we get something like this. Plus 24.55, and there we go. That's the answer to part A. When you expand that function h of t, you'll get this, okay?
Mm-hmm.
So that's the answer to A. Part B, how high is the cliff? Now look at this. What does this represent? What is that? That's the y-intercept, okay?
Mm-hmm.
Can the person be above the cliff? No, right? The person has to be right here for them to jump. So what's the y-intercept here? Always look at the standard form. You're trying to find y-intercept.
24.55.
Exactly, so there we go. The height of the cliff is 24.55 meters. Part C, when does Jude hit the water? So now what are we looking for? The x-intercept, okay?
Mm-hmm.
We are looking for the x-intercept. Any ideas on how to find that? How do we find x-intercept of a function? What's 0 at the x-intercept? Something is 0 here.
The y value.
Yeah, the y value is 0. So we're simply gonna set the y value as 0 and then solve it. So there's two ways to do this. Either you can use the original one or you can use the standard one. The standard one, unfortunately, it's not manable because this is gonna give you some decimal number and then, yeah, Man is strictly only for whole numbers. Okay. So even though this is a quadratic, it's a quadratic trinomial. We would man this, but because the numbers here are a little bit weird, we are not allowed to man it, or it's not going to work out. So instead of using the standard form, I'm going to use the vertex form up there. So y value 0, y is just h of t minus 5, t minus 0.3 squared plus 25. So this is what we need to solve. What do we think we do first? We're trying to solve for t.
You could subtract 25.
Yeah, that's perfect. That's exactly what I would do. What about after that? Let's subtract 25.
Do you divide by -5?
Yes. So you get 5 equals t minus 0.3 squared. What do we do next?
You open the bracket.
Don't do that because you're going to get some funky numbers when you can't man it. You could open the brackets, right? But if you do that, it's going to become unmanageable. It's going to be a quadratic trinomial like it's here. We're going to get some weird numbers. What if it was like this? What if it was t squared equals 5? What would you do to solve for t?
You would find the square root of 5.
Yes, you would square root both sides, right?
Mm-hmm.
Same thing. We're going to use the same thing here. We're going to square root both sides. Okay. What's the square root of 5?
2.2 something.
Was that the only answer here? What's the square root of any number? There's two. You're going to get two things. Okay. It's always going to be plus minus at this level.
Okay.
The square root of 4 is plus minus 2, right? Same thing. The square root of 5 is going to be both of these. And now look at this. We have this plus minus element. It's not a big deal at all. It just means we have to split it. So either the positive 2.24 is t minus 0.3. So one of the t values is going to be 2.54 seconds, right? And the
Mm-hmm.
other one is going to be the negative of plus minus. So negative 2.24 equals 2 minus 0.3. And that should give you, I believe, 1.94 equals t seconds. So this negative 1.94 is here, you see? Because a negative number must be to the left of the y-intercept. And this x-intercept is 2.54. We don't really care about this guy, right? Because it's not in the domain of our function. Time can never be negative. So the answer to C, when does Jude hit the water? It's going to be 2.54 seconds. After 2.54 seconds, she's going to hit the water. Cool?
Mm-hmm.
So this one is a mathematically correct answer, right? It's mathematically, it's fine. But the issue with this one is because it's a real life problem, right? We also need to think about the real life, the practicality of it. And this one is not a practical answer because time will never be negative unless you go into like a spaceship time traveling machine, which is also not possible. That's a talk for entire time. It's like, well, we don't know a whole lot. We know a whole lot, but we still don't know a whole lot about how the universe really works. Our current standing of physics tells us that time travel is not possible, but who knows, right? In the future, like who knows? Anyways, that answer is out. D, determine where the function is negative. When they mean the function, they mean the y values, okay?
Mm-hmm.
So look at the graph. When are the y values negative? Look at the graph. After which x value, right? Look right here. After which x value is the y value is negative?
2.54.
Exactly. So when the function is negative, when x is greater than 2.54, right? H of t or the y is negative. What does h of t, what does y being negative tell us in the context of this question? What does that actually mean? See, h represents the height, right? The height of the diver above the water. So if the height is negative, it means what?
You're underwater.
Exactly. So after 2.54 seconds, Jude will be underwater or below the surface level, whatever. Okay,
Mm-hmm.
there we go. So this one we did some quadratics, right? But this quadratic was unmannable. It's always you can't man it if you get like a weird number like this. Usually it has to be like nice whole numbers. Let's try doing this one. The goal is to solve for x. What's the first thing we do on all three sides?
Do you multiply by 2?
That's perfect, exactly. So you get 4x, 3x plus 6, 4 plus, again, when you multiply by 2, you have to do it on both of these sides. It's going to become 8 plus 4x. What is next? So I'll give you a hint. Yeah? You're going to be
Could you
left with an
subtract
x.
6?
Subtract 6? Yes, you can. So 4x minus 6, 3x, and then 8 minus 6 is 2 plus 4x. So the goal at the end is to just have an x in the middle, okay?
Mm-hmm.
What's next?
Divide by 3?
No. Because we only want x in the middle. You can't have an x here, you can't have an x here. If you divide by 3, you'll get something like this. There's still x's here and here, so no, not divide by 3. It has something to do with the x's here and here. We need to do something with these guys.
Divide by 4?
Divide by 4 doesn't cancel out. Subtract 4x from all three sides. We only want x in the middle, right? So we need to get rid of the 4x here, 4x here, subtract 4x from all three sides. So you get negative 6, negative x, and then 2. There we go. Okay?
Mm-hmm.
But we're not looking for negative x, we're looking for positive x. What do we do now? We multiply by -1 on all three sides, okay? Because we want an x in the middle, so we would multiply by -1. So if you do that, the signs would flip, right? And there we go, that's the final
Mm-hmm.
answer. So what does that mean on a number line? So when x and 6, it's between a -2 is inclusive, 6 is not inclusive. There we go, and that's the final answer.
Okay.
Here, let's look at this question. Now we have a cubic inequality, all right? what I'm gonna do is I'm gonna give you the x-intercepts because I just want to tell you how to do this. Like, what's the idea behind it? To find the x-intercepts, we're gonna have to use the factor theorem. We're gonna have to look for the factors of 12, right? That when you plug in as x, you get a 0, and then you do a synthetic division, you find all the x-intercepts. But let's say we have all the x-intercepts. How do you solve this question? There's two ways. One way is better than the other, and it's the graphical way. So this is a cubic function, a positive cubic function. It's going to start here, it's going to end here. The y-intercept is 12, the x-intercept is 1, 1.5, 3/2 is 1.5, and a -4. Then the best part is connect the dots. There you go, that's a sketch of this function. Greater than 0 means for which x values, okay? For which x values are the y values positive? I'll give you a hint. Y values are positive right here. You see these are the positive y values. There's also a positive y values right here. Positive y just means above the x-axis. Any ideas? No? It's easier than you think. Well, the y values are positive when the x values are between -4 and 1, right? That's one of them from this chunk. What about this? How do we represent this? Well, the y values are positive when x is greater than which number?
1.5.
Yeah, there we go. That's all. So the answer is this and this, okay?
Okay.
What if I asked you, what if instead of being greater than, it was less than 0? So what would be the answer now? So now we're looking for negative y values. For which x values are the y values negative?
And x is less than -4.
Yeah, that's one of them. What's the other one?
When x is between 1 and 1.5.
There we go. 1 and done. You see, that's the answer. Easy as that. Okay. But that required us to find the x-intercepts, which is a little bit more difficult, right? Let's look at this question. Again, to solve something like this, you're gonna first need the x-intercepts. How do we go about finding the x-intercept for something like this? What is the degree of this polynomial?
Degree 3.
Yeah, exactly. How do you solve polynomial equations? Same thing with quadratics. You want one side to be equals to 0, okay? You need one side to be equals to 0. So what we're gonna do is we're gonna toss all three of these guys on the right-hand side to the left-hand side, okay? So we would do -2x² on both sides, -14x on both sides, +16, add 16 on both sides, which gives us x³ minus -2, -2 means 4x². +5x minus 14 means what? How many x's are there? There's 5x here. We're gonna subtract 14x from both sides. How many are we left with here?
-9x.
Yeah, -9x, and then 20 plus 16 is 36. There we go. Greater than, equal to 0, right? Step 1, toss everything to the other side. Now what? To find the x-intercepts, we have to factor this.
Do you find the factors of 36?
Yes, you do, which is plus minus 1. And there's no way 1 works in here. Look at this. Doesn't matter if it's positive or negative. It's not going to be big enough to kill the 36. So you can just ignore the 1. I'm going to start with 2's, and usually one of these will work out, right? Why don't you try -2? and tell me what you get.
I got 30 for -2.
All right, so that's -2 is out, right? And then we gotta do +2. +2 doesn't work either. +3 works. Okay. +3 works. That means x minus 3 is a factor of this. And we know +3 work. That's gonna be our k value. So we do synthetic 3 here. What are the coefficients up here?
-4, -9, and 36.
You're missing one of them, the first one.
1.
1, exactly. 1. And then this is gonna drop. So you have 1. 3, -1, -3, -12, -36, 0. Boom. So we can rewrite this guy as x minus 3 times what? What's the quotient? Look down here.
X squared minus 1x minus 12.
Exactly, minus 12. So this one, this is a quadratic that's definitely manageable, right? There's no decimals, there's nothing fancy going on. What does it multiply to? What does it add up to?
It multiplies to 12.
No. Close, but not close enough. -12. What does it add up to?
-1.
What are the numbers? There's only 3 things that multiply to 12. One of them is 1 and 12. There's no way any variation will ever add up to a -1, right? The next one is 2 times 6. You can either add up to 8 or 4, not to 1. So 2 and 6 is also out. The third one is 3 and 4, right? So if it has to add up to -1, which one of these is the negative number?
3 and -4.
Yeah, exactly. There we go. 3 and -4 are our numbers, okay? It's pretty easy to think about it here. Look at this. Let's say we have -24, and let's say it adds up to, I don't know, 5, -5. -24, you can either have 1 times 24, that will never add up to 5. Then you have 2 times 12, no, that's 14 or 10, yeah? The next one would be 3 and 8. That can definitely add up to 5. In this case, it's gonna be 3 and -8, you see? That's the way to think about it. Anyways, if the leading coefficient of your quadratic is 1, which it is, you can just rewrite this as x minus 3, and the quadratic, you can factor them as x minus 3, x plus 4, okay, like that. There we go. So what are the x-intercepts here?
+3, +3, and -4.
Yeah, +3, +3, and -4. If you have multiple, if you have a repeating, right, this means it has at 3, there's a double root. Okay? What does double root mean for us?
There's a turning point there.
Yeah, exactly. There's a turning point there. Right? Now let's look at this. So now we can finally graph this entire thing. We know the y-intercept is 36. And we know this is a positive cubic, gonna start in Q3, gonna end in quadrant 1. And we know there's one at -4, and at +3, there's a turning point, right? So it's gonna look like this here, and then you just connect the dots. Now, what do they want? They want greater than and equals to 0. That means, again, that's just a fancy way of saying positive. For which x values is this graph positive?
When x is between -4 and 3.
Yeah, that's one of them. And by the way, now look at the symbol. Because it says equals to here, right? Last question, it was strictly greater than, but now it's equals to. So our answer is also going to have that equals to symbol, okay? When x is between -4 and +3, where else is it positive?
When
Here.
x is greater than 3.
Yeah, greater than or equal to 3. There we go. That's the answer, okay?
Okay.
In fact, when x is greater than -4, the y is positive, greater than equals to. And just combine both of these.
Mm-hmm.
And that's how you do that. Cool?
Mm-hmm.
I'm gonna show you another way of doing this, because not always will you be able to graph this. Because to graph it, you're gonna need to find x-intercepts, and you'll see eventually factoring them is gonna be pretty tedious. Anyways, so now instead of doing the graphical approach, which I think is more efficient, it's definitely easier, right? Sometimes they may ask you to use something called a sign diagram. Now, what in the world is this? Look at this. So we know our 3 x-intercepts are actually it's 3, 3, and 4, yeah?
Mm-hmm.
So we're gonna make something called intervals. Okay? Intervals always go from left to right, so from -infinity to +infinity, like this. On a number line, our answers are here. So there's a -4, that's one of our x-intercepts. There's a 3, right? So to turn this into intervals, it's going to look like this. The first interval is going to be from -infinity to -4. The second is going to be between -4 to +3. And square brackets here just means it's inclusive because the question's inclusive. The next bracket is going to be from 3 to infinity. Okay, those are intervals. Here's interval 1, interval 2, interval 3. And now, instead of graphing it, we're going to deduce algebraically whether it's positive or negative. So step 1 is to make the intervals using the number line and the x-intercepts. Step 2 is to do this. X minus 3 is there, x minus 3 is there, x plus 4 is here, and then we have the entire thing, which I'm going to call f of x, okay? Now, how does this even work? Think of an x value between -infinity to -4 and plug it in there. So for example, -10 is in that interval. So if I plug x as -10, I get -13, which is a negative result, right?
Mm-hmm.
Well, x minus 3, it's going to be the same thing, x minus 3. We also got the third one, x plus 4. So again, I'm going to plug -10 because it's in this interval. -10 plus 4 is -6, so that's also negative. What is negative times negative times negative?
Negative.
Negative, exactly. But we want a positive answer, so this interval is out. Okay? Now just keep going like that. Think of a number between -4 and 3. The easiest one, this one, just think of 0. 0 is the easiest, okay? 0 minus 3 is a negative number for the first one. First and second ones are the same. So you have a minus number for the first, minus number for the second. 0 plus 4 is a positive for the third. What is negative times positive?
Positive.
Exactly. We wanted a positive, so therefore this is one of the answers, which we knew this before. 3 to infinity, I'm just going to think of 10, positive 10. 10 minus 3 for the first one, positive 7, positive 7. 10 plus 4, 14, positive. Triple positive means positive, and there you go. Our answer is between -4 and 3, and 3 and infinity. This should have been a square bracket because it's inclusive. But we already knew this graphically, right?
Mm-hmm.
So there we go. That's our answer is right here. This and this. So that's how you do it algebraically. And unfortunately, well, polynomials are easy to graph, but this method works for any function. you'll see we're gonna run into something that's gonna be pretty difficult to graph. And for that one, the graphical approach fails basically for that one. This way is way better, the sign chart approach, which is the algebraic approach. Cool?
Mm-hmm.
Yeah, see this one, it says, solve them algebraically, right? Algebraically means a sign chart. If it doesn't say anything, you can use whichever method you like, but I guess you can't use the graphical approach here. Look at this, we have a cubic polynomial. How do we factor this?
You can use the man method.
We can use a man method? No, man method is only for quadratic trinomials, degree 2 polynomials. Doesn't work for degree 3.
So then what do you do?
Well, for a higher degree, from 2 and above, right? From degree 2 and above, you want to bring everything to the same side. So you'd bring this here, okay?
Okay.
So you get something like this. Now you got to use the factor theorem. What do we do next? We need to factor this guy.
You find factors of -6.
Yeah, which is 1, 2, 3, and 6, right? Look at this. This one's pretty simple. It's just gonna be 1 because positive 1. 1 plus 4 plus 1 is gonna be 6. So plus 1 is gonna work for sure. That means x minus 1 is a factor, yeah?
Uh-huh.
So we're gonna, our k value is 1. What are the coefficients?
1, 4, 1, and -6.
Yeah. 1 is gonna drop as it is. 1 times 1 is 1. Add them 5. 5 times 1 is 5. Add them 6. Positive 6 is 0. So we can rewrite this cubic function as x minus 1, our divisor. And what's our quotient?
X cubed plus 5x plus 6.
Not x cubed.
Oh, x squared.
Yeah, x squared, because we divided x cubed by x. So the power drops by 1. So 5x plus 6. And that's a quadratic. That one is a definitely manageable, right? It's not a funky looking quadratic. This one is it has nice whole numbers. How do we factor this quadratic?
Now you use the man method.
Right. What does it multiply to? What does it add up to?
It multiplies to 6 and adds up to 5.
What are the numbers?
6 and -1.
That would multiply to -6. Try again. 6 and -1 is out because it multiplies to -6, not positive 6. Think of what else multiplies to 6.
2 and 3.
Right. And again, the leading coefficient of this quadratic is 1. So our numbers are 2 and 3. When you're writing it, make sure to flip it. It's going to become x minus 2, x minus 3, okay? Just like how our k value initially for the synthetic was 1, but over here it's going to be x minus 1. So what are the x-intercepts?
1, 2, and 3.
Yeah, 1, 2, and 3, right? 1, 2, and 3. I know it's telling us not to do this graphically, but I'm just going to show you to confirm the answer. So 1, 2, 3, positive cubic, the y-intercept is -6. So it's gonna go here. There's no turning point shenanigans. Gonna go down, gonna come up, and there we go. That's the graph. So when is this greater than, oh, sorry, when is this less than 0, which means negative, less than or equals to 0? There's two answers for this one. Look at the graph. When is the function negative for which x values? It's negative right here. That's negative right here. Like here, it's
When x is less than 1.
yeah, when x is less than 1, right? Less than equals 2. The other one is between when x is between 2 and 3, yeah?
Mm-hmm.
I'm going to show you how to write this in interval notation, which uses the number line, okay? When x is we know we go from negative infinity to positive infinity, and our interesting values are 1, 2, and 3. So when x is less than negative 1 means this direction, right? So in interval notation, you can rewrite that as negative infinity, but positive 1. Infinities are never inclusive, but this one is inclusive, so we're going to end that with a square bracket like that. This is a set notation using x's. This is the interval notation, okay?
Mm-hmm.
Between 2 and 3, well, we're looking at this chunk right here. There's no infinity shenanigans, so it's just going to be 2 and 3, and they're both in square brackets because they're both inclusive, right?
Uh-huh.
So that's how you go from one notation to the other. Now let's try doing this algebraically. We know our, let me just keep this here. We need to check it here, we need to check it here, we need to check it here, and we need to check it here, okay? Now there's 4 different intervals that we need to check it for. So we have negative infinity to 1. Then we have 1 to 2. Like, what does that mean? We just want to see what the graph is doing here, whether it's positive or negative, but we're doing this algebraically. Between 2 and 3, what's the last interval? This one.
3 to infinity.
Yeah, 3 to infinity, and infinity is never inclusive like that. Boom, 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 boom. And then our factored guys are x minus 1, x minus 2, x minus 3, and then the entire thing f of x. All right, so we're looking for a number between negative infinity and 1. Well, 0. 0 minus 1 negative, 0 minus 2 negative, 0 minus 3 negative. What's triple? Triple negatives. What does that multiply to?
A positive.
Triple
Negative.
negatives? Negative, right? Yeah. Now let's look at this. What's the number between 1 and 2?
1.5.
Exactly. So 1.5 minus 1, that's a positive. What about 1.5 minus 2? Is that positive or negative?
It's negative.
It's negative. What about 1.5 minus 3? It's also negative. So what does this multiply to? Positive, negative, negative?
Negative.
No, positive, right? Positive times negative. Well, positive stays as it is. Negative times negative is a positive. So positive, positive, positive. See?
Mm-hmm.
It's a number between 2 and 3. Well, 2.5. 2.5 minus 1 positive. 2.5 minus 2 positive. 2.5 minus 3, though, is negative. What does plus plus minus give if we combine them?
A negative.
Exactly, a negative. 3 to infinity, we can take 10. It's all going to be positive. The entire thing is going to be positive. Therefore, the answer is between 1 and 2, right? No, we're looking for
Mm-hmm.
negative. We're looking for negative. Sorry, we're not looking for positive. We're looking for less than. So our answer is between negative infinity to 1, which is one of them. Infinity is never inclusive. And then the next answer is between 2 and 3, which is what we had from the graph, if you see. Right? What if we got these answers from the graph? And we got these answers algebraically. So you can pick either one of them, right? But graphing is definitely easier though. Yeah?
Uh-huh.
Which one would you pick if you had a choice?
The graphing.
Yeah, this one's a little bit tedious, but you'll see why we're learning this because we're gonna end up with some functions that we don't know what they look like. Now this one is T's. T's for thinking. You don't really need to do a lot of math. It's more like a puzzle. It says, without using a calculator, explain why the inequality has no solution. Any ideas whatsoever? No solution means it will, so we want to find when this f of x is less than 0 or negative. So it's basically telling us that it'll never be negative. That's what no solution means.
What about the second one?
No. So the answer to the first one is this. You see, this is a even degree polynomial, right?
Mm-hmm.
Starts here, ends there. What's the y-intercept? It's positive 80, right? So the answer to this is it never crosses the x-axis. That's why it'll never be negative. That's why this doesn't have a solution. Okay? It probably has 23 turning points, possibly. But we don't know that. But because this graph is always going to be above the x-axis, that's why there's no solution, because it's asking us for negative. Less than 0 means negative. That's the answer to A. The answer to B, look at this. Again, which quadrant does this start in? It's a negative even degree polynomial.
The third one?
Yeah, starts in third one, ends in fourth one, right? The y-intercept is 20, yeah? So probably does something like this. And it's now this question, B is asking us, when is this graph less than this other graph, which is a quadratic with a y-intercept of 30, right? Like that. Quadratic positive means it goes like this. So look at this. When is the black one less than the green one? Or lower on the graph than the green one. Everywhere, right? You pick some x value, it's lower here. You pick some x value here, it's lower here. It's lower everywhere, and everywhere means negative infinity to positive infinity. The entire number line, okay?
Okay.
So this even degree 12 polynomial is less than our quadratic everywhere because graphically it's always going to be underneath it. It's always going to be lower. Lower means less than, right?
Mm-hmm.
So that's how you think about that problem. Let's try doing this rock problem that we did before, but last time it was not in standard form, but now it is. What's the degree of this polynomial?
Degree 2?
Yes. Positive or negative?
Negative.
Negative, right? And we know the y-intercept is 14. So it's gonna come upside down. But again, what does the x-axis represent in this case? What's the independent variable?
Time in
Time,
seconds.
exactly. Time in seconds is on the x-axis. Height, h of t, in meters is the y, the dependent variable. We don't really care about this part here, negative time. So I'm just gonna kill that. So the graph is gonna look something like this. How high is the rock off the ground when it is thrown? That's just a fancy way of saying what's the initial height? Initial height means what? This right here. The y-intercept. What's the y-intercept?
14.
14. All right. And by the way, this is not a sea question, like a water question. It's being thrown into a ground. So we actually also don't care about the negative y-axis. because it's not gonna penetrate the ground and go to China, you know. It's gonna stay right there. Is that actually true? Do you know? Where if you keep digging, you end up, I don't know if you've heard of this. What do you think? You're here, you keep digging underground, you end up in China.
How do you end up in China?
Is that a fact? Because it's on the other side of the globe, right? Like say China is here, Canada is here. You dig, you end up there. Is that fact or is that fiction? What do you think?
I mean, I don't think you could dig that far.
Mm. We do dig pretty deep though, like especially for like oil and stuff. Dig way down kilometers into the Earth's crust. Well, this is not possible because the closer you get to the center of the Earth, right here,
Mm-hmm.
the hotter it gets and gets really, really, really hot. We don't have anything that's not gonna melt. Okay. This is technically right. I don't know. If you look at a globe, it's right, but practically it's not possible. Anyways, yeah, so our y-intercept is 14 meters. How long is the rock in the air? So we're looking for this distance from here to here. That's just another way of saying find the x-intercept, right? So we can use a man method here because this is a quadratic. What does it multiply to? It's going to multiply to -5 times 14, okay? So it multiplies to -70. You see that?
Mm-hmm.
What does it add up to? It adds up to 12. Now, what are the numbers? That one's a little bit tricky, right? If you think of what multiplies 70, 1 and 70, forget about that. 235, forget about that. 3 doesn't go into 70. 4 also doesn't go into 70. So the closest one is 5 and 14. There's no way that adds up to 12, yeah? What else goes into 70? 6, I don't think does. 7 does. 7 and 10. Does that add up to 12?
No.
8 doesn't go, 9 doesn't go, 10 is already used. 12 doesn't go, 15 doesn't go, 14 does, but we already used it. So what do you do in a case like this? So this is another instance where it looks like it's unmanageable. You want to use the quadratic formula, which looks something like this. We've done this before, but it was a while ago. It's negative b plus minus b squared minus 4ac over 2a, where a is -5, b is 12, c is 14. I'm just gonna quickly do this. I can just do this on a calculator. So -12 plus 12 squared minus 4 times 14 times -5 divided by -10. So the answer to this is change, please. No, that one gave me the negative answer, so I need to try for the other one. -12 minus b squared minus 4 times 8 times c divided by -10. There we go. The answer is 3.26, okay?
Okay.
So this one, I guess, I'll show you how to use the quadratic formula. Yeah, this one was unmanageable. So today we saw two instances where even though we had a quadratic, the man method didn't work, right? The
Mm-hmm.
man method is good to factor it. But the issue with a lot of quadratics is that they're unfactorable. Doesn't mean they don't have x-intercept. It just means you can't write them as something times something. So to find the x-intercept in that case, you would need to use the quadratic formula. It's okay, we can work on this tomorrow. Let's call it a day for today.
All right. Thank you.
All right, bye-bye.